Let us see another problem on CDF. So the problem is a coin is tossed 3 times. This means that one coin is tossed 3 times uh, successively, or we can say the 3 coins are tossed at a time. So a random variable represents number of heads appearing in each trial. So when you toss 3 coins at a time, or one coin at consecutively 3 times, so uh, you have to see how many heads are appearing in that trial. So that is the random variable. So first step in CDF is finding the sample space. So for finding the sample space, you should see what is the random experiment. So the random experiment here is, it is tossing coin 3 times. That means if you toss a coin for 3 times, you will either get head or tail 3 times. That means in first toss you will get head or tail, in second toss either head or tail, or in third toss either head or tail. So accordingly the sample outcomes will appear. So uh, it could be that on all 3 tosses you will get tail, tail, or either you will get head, or tail, head, or tail, tail, head, or head, tail, head. Now the easy way to write this is, you know the binary 3-bit representation of the numbers. So accordingly you can write these sample outcomes. So you know that 0, 000, then 001, 010 likewise. So 0 for tail and 1 for head. Otherwise, this is one method. Otherwise you can write there like this also, that 3 tails appears, 3 heads appears, 1 head appear, 1 head appear, 1 head. So if 1 head appears, so this head, then you have to move this head circularly, so it will go to here, this side, then this one. After that it will go again here, so stop here. After that take 2 heads, so 2 heads, then shift it to this side, so head, then again shift this head to this position, then tail and head. So likewise also you can write the sample outcomes. Now this is up to sample outcomes. Now what is the random variable? You have to count number of heads. So random variable is number of heads appearing in in each trial. That means if you toss a coin 3 times, then at that time how many heads appear? So heads could be 0. That means there could not be any head in that in 3 toss trial, or there could be 3 heads or 1 head, and that position could be in first toss or second toss or third toss, or there could be 2 heads in first and 2 toss, then second and third toss, or first and third toss. So these are the random variable values. So x is a random variable which mapped these sample outcomes to the real numbers. Now if you observe this, it has the values 0, 1, 2, 3. So this random variable x has the value 0, 1, 2, 3. So it is denoted by for example x0, x1, x2, x3. You can take any alphabet like y0, y1, y2, y3. If you take y0, y1, y2, y3, then you have to take random variable capital Y. So it would be easier for the representation. So after that, what is the probability of triple T? So it could be probability of getting tail in a coin toss is 1 by 2, getting head in a coin toss is 1 by 2. So this has 1 by 2 into 1 by 2 into 1 by 2. So this has the probability 1 by 8. This has a probability 1 by 8. This has a probability 1 by 8. So every sample outcome has the probability 1 by 8. Okay, because these are 8 outcomes, so obviously it is 1 by 8. Okay, so mm, so this is one point. Now you have to find the probability of random variables, random variable values. So probability of random variable values. So random variable has values x0, x1, x2, x3. So probability of x0 is probability of triple t, so that is equal to 1 by 8. Now probability of x1 means probability of getting one head. So one head has appeared for 3 times. There could be the uh, three positions where one head can appear. So each outcome has the probability 1 by 8. So 3 multiplied by 1 by 8, so that is equal to the probability of x1. X2, that is number of heads equal to 2. So number of heads equal to 2 appear. This has the possibilities of 3 outcomes, like THH, HHT, HTH. So each has the probability 1 by 8. So 1 by 8 into 1 by 8 into 1 by 8, so that is equal to 3 by 8. So 3 into any of the probability of any of the outcome you can write, because every outcome has probability 1 by 8. Now probability of x3 is probability of triple H, that is equal to, that is only one outcome, so that is equal to 1 by 8. So here we have found the probabilities of random variable values. After that you have to find the CDF. CDF is obtained at that random variable value. So fx x0, for that you have to take only this 1 by 8, because before x0 there is no probability, so 1 by 8. So fx x1 has the formula of taking this fx x0 plus this probability 3 by 8. So 1 by 8 plus 3 by 8 is 4 by 8. So fx x2 is take 4 by 8 previous CDF, so 4 by 8, and take the probability of x2. X2 is 3 by 8. Now fx x3, take the previous CDF, so 7 by 8, and probability of x3, that is 1 by 8, so that is 8 by 8. So finally you are getting 1. Now how to plot it? So px, probability of random variable value, and this is random variable. It has values x0, x1, x2, x3. Probability of x means, so it could be capital X only, because capital X is taking the value x0, small x0, x1, x2, x3. So x0, probability of x0 is 1 by 8. Then probability of x1 is 3 by 8, 3 by 8, 1 by 8. So 1 by 8, 3 by 8, 3 by 8, 1 by 8. So fx before x0, that is 0. Fx CDF is 0. At x0 CDF is 1 by 8. At x1 it is 4 by 8, then 7 by 8. So at x1 it is 4 by 8, and it continues, because CDF is a continuous function, and it is either constant or increasing. So 4 by 8. At x2 it is raised to 7 by 8, and it remains constant up to x3. At x3 it rises to 8 by 8, that is 1. It rises to 1, and it continues. Okay, so this is the problem on CDF.